Hi, good afternoon, all of you. A very warm welcome to all the teachers and Ms. Rakhi Chawla, our speaker today. So, today we are here to talk about National Mathematics Week. We are here to celebrate the National Mathematics Day. And during this entire week, we'll be talking about different mathematical help that we can provide to deliver mathematics in a better way to our students. So, why National Mathematics Day is celebrated? So, National Mathematics Day is celebrated every year on 22nd December to honor the birth anniversary of Srinivasa Ramanujan. Ramanujan gave almost 3,500 mathematical formulas to the world that scientists have still not been able to prove completely. He is recognized for his mastery on continued fraction, hypergeometric series, Riemann series, functional equation of the zeta function, and elliptic integrals. We at ESCHAN are not only celebrating National Mathematics Day, but have extended the same throughout this week. To do so, we have an impressive series of CPD sessions by experienced subject matter experts. Through our sessions for the entire week, we aspire to facilitate CPD sessions in which subject matter experts will share best practices that they have experienced over the years. So what comes your way is wisdom which may be ready to use in your teaching context. Get ready for tips and tricks to teach mathematics in an experiential way. Our speaker for today will be Ms. Rakhi Chawla. A brief about Ms. Rakhi Chawla is that Ms. Rakhi is the founder of Ed3D STEM Tinker Learning Private Limited, an edtech organization with a vision of transforming how STEM courses are taught and learned. Rakhi and her organization developed STEM curriculum designs STEM's hands on learning tangible products, innovative games, frugal learning aids, out-of-the-box thinking workbooks, and online courses. During this session, we are to keep in mind some housekeeping rules. So the basic housekeeping rules during this session will be to keep yourselves on mute during the entire session. Please use your chat box for any question and answers. Please fill the feedback form received at the end of the session to receive the certificates. The emails will go out to each one of the participants here who have registered for the session automatically once the session is over. Please also register for our sessions planned for the entire week, if not done already, which is via our newly introduced CPD Corner website on www.eschanpublishing.com. The links for the website will be sent out through chat box time and again during the entire session. So again, a very warm welcome to all of you, and I would like to hand over the session to Ms. Rakhi Chawla from here.
Hello, everyone. Thank you, Himanish, for a wonderful introduction and setting the tone up.
You're welcome, ma'am.
Great. So as Himanish told, that we all are here to celebrate the National Mathematics Week, and this has been a very close week to my heart because every year there are some of the activities planned around this week, and we do a lot of hands-on activities and take the teachers to the next level. I hope we can make the most of the session today as well, and hope you take away a lot from this 1 hour session. So the session today is about, like most of you must be knowing, the CPA approach now, which is the concrete, pictorial, and the abstract way of learning mathematics. So what basically concrete, pictorial, and abstract maths is, that all the kind of maths we have been learning throughout our generation. Can we keep mute? Can we keep ourselves on mute, please? Okay, so basically, what all we have been learning throughout our mathematics journey in school, most of cramming the formulae and solving the theorems and the word problems without even thinking that actually what's happening and where the real life application is, and even if can we relate some a visual approach to it before even solving the problems. So now we are leveling ourselves up in this generation at least, and we hope that teachers also level up themselves to get into this next level of generation who are more tactile learner and kinesthetic learner, the kind of a Gen Z generation what we talk about. So when we talk about that, so we are okay, so we are here. So we right now, first step is that how do we plan our lessons? That is what our first expression of thought is. That if you would have attended my last workshop, we have been we did a lot of fractions, how to introduce fractions to children in the CPA approach. So basically, how the C stands for concrete, where children have things in hand and they can play around, and there are a lot of things available in the market, and there's a lot of scope of teachers to invent their own tools wherein children are actually working with hands, right? So it's a hands-on minds-on learning. Now once they have developed the basic sense that what basically the how to uh, understand the problem in a concrete way, can we draw them, can we draw diagrams around that, can we visually learn them? So there's a lot to connect from concrete to pictorial approach. And once children have based their foundation on concrete and the pictorial, so now they are in the hands-on learning and minds-on learning, they can visualize, they can hear, they can talk. And once they have settled down their fundamentals, their foundation, the next step is the abstract approach, where our numbers and symbol and formula and the basic process procedures what we do, they come on handy. So this is the whole journey of when we talk about the CPA approach. So now the discussion is that how do we plan the lessons around the CPA approach, even if it's not CPA. Can I would like to hear few of you, how do you plan your lessons in the most interactive way, and what can we do on top of that? So that would be the wonderful thing for our next generation classrooms. I call them chef classrooms, because as a chef, it's not like a basic cooking what we are doing at home. It's like, you need to visualize, you need to experiment, you need to beautify your lesson plan so that they are very eye pleasing, they are tasty, and they are close to heart. So that's what we want to bring maths to the next level, to beautify the whole thing basically. So if some of you can volunteer to share your experience of the experiential classrooms, what you do in, so that would be great. So are there any teachers who would like to share their experiences in the classroom and where they fall short with the students, because students are very smart these days? Anyone, I mean, that's it's an open forum, so anyone can tell their experiences.
Ma'am, we teach with teaching aids. We have some teaching aids with us. Like today I did volume and net. So I kept cube and cuboid with me. Many blocks I kept with me. With that, those things I explained them. Practical knowledge was given.
Okay, that's nice.
Am I audible, ma'am?
Yes, you are audible.
So anywhere, wherever we like fraction for fraction, we bring different things, and live demonstration is given of the topic.
So
This way
can you
we plan our
explain?
lessons.
Okay, so can you explain what kind of tools you get to the classroom?
Like I told na, today I took different things,
like your
having different
fractions, for
shapes.
example.
Cube, for cube, I took the Rubik cube, and for cuboid, I took boxes of different lengths, and I showed them the things also. Like I kept it together and showed them how it will look from front view, back view. For nets, I took boxes, I opened it and showed them the nets. So things, we carry things with us
That's
to
nice.
show
That's
them. And
okay.
activity, it is also activity. They have to do the activity also. Same they have to do. Then nets, like they can paste net of cylinder, net of cuboid in their notebooks.
That's very interesting. So how do you, so open question for everyone, because as Miss Taranjeet, right, she
Yes.
introduced like a cylinder. So,
Hmm.
and we are coming from a 2D shape to a 3D shape, for example. In how many ways, like, would you uh, tell a child that a cylinder can be made?
आएंगे है ना हाँ जी अरे बाप रे अरे
Like
Sapna ji, can you
अरे
please
आप लोग बहुत करते हो
just
यार बहुत
same way we can use
जी जी
two circles and one rectangle and tell them to make it in the class. Activity they can do.
okay.
Hmm.
Okay, so there is one way to look the cylinder as that you rolled a rectangular strip and you
Yes.
made a rectangle and you kept a disc
Two
of the
faces,
same radius on the top and
circle.
the bottom your cylinder
Hmm.
is made, right? Can
Yes.
you visualize cylinder in some other 2D shape?
Yes, different things it can be like cell, tube light. Examples can be given.
No, I'm not saying that. I'm not saying real life example. I'm saying, so for example, we teach 2D shapes, right? So if you see a cylinder is a 3D shape made up of
Circle.
a circle and a rectangle, right?
Rectangle. Yes.
Can you all visualize cylinder as a different 2D shape?
Two-dimension shapes.
Yeah.
Yes, ma'am. It can be a parallelogram. Hello.
How can
How
you
parallelogram?
make a
If
parallel?
it is not a right circular cylinder, then
Okay,
it
no,
can.
I'm talking about the right circular cylinder, the basic cylinder what we teach in the classroom.
Then
So
I
it's
we
basically like visualize that. How do you visualize any shape as, right? One way is rectangle ko we folded and we made a cylinder. Is there any
Yes.
another way to look cylinder
Mm,
as?
yeah, ma'am. One more.
Yes, please.
Yeah, is square and circle.
Yeah, so square and rectangle fall in the same family. So basically, can you think of, was somebody
Pile
saying
of the coin. It's a pile
Prabjot?
of the
Can
coin.
Prabjot, can you instead of putting in the chat, can you just speak up? And that's a wonderful answer.
Yes, ma'am. If we place circles one over the other,
if
yes.
circle on
if we
circle, then circle.
place so if we place concentric of the same radius cylinders, circles on top of each other, so it's not only about the folding thing, it's like stacking one on top of each other, the concentric circles of the same radius, right? We'll have a cylinder. So now you have two ways to look at the cylinder, not only like a rectangle folded, but discs placed on top of each other, like you when you go to some buffet or some wedding party or something, you can see plates stacked on top of each other, the circular plates, right? That forms the cylinder basically. So you can view cylinder in two different ways. So that is how basically it's not about only taking the things to the classrooms. It's basically what we can do different things, different activities, different concepts with those same objects. So that is where the experimentation and innovation with the the concrete thing comes into picture. And I would really request right now, if I'm asking something, can you please speak up instead of putting in the chat? Otherwise, it's like I have to put my energy into two things and I'll just miss Yeah, so few 1 rupee coins also, and if we play circles, that's okay. Great. So let's start our lesson planning session. That how would you take it up? So just a second. So hope you all can see now. So okay, so this is the big one of the very what do you say, a tough problem for me when I was a child. So maybe just imagine you're in second or a third grade and you start introducing the division problem. And this is how the division was done. And despite of scoring 10 on 10 or 100 or 100 on every other concept, division was one of the thing where I did several mistakes. I don't know why, but it used to happen. And when I teach also, this is a common mistake with most of the children when division comes in picture. So can anybody tell me actually what's happening over here when we are saying 156 divided by 12, and you say, okay, so 12 ones are 12, and we have 12, and then the 3 is the remainder, and then we pull down 6, and now it becomes 36, and 12 threes are 36, so that means 12 13s are 156. So can anyone tell me what's actually happening over here, where this 1 is coming from? What do you mean by this 3? What do you mean by this 12? Because children can't relate to it. It's an abstract notion of learning something. So yeah, so can anyone explain me how do you take this long division algorithm to the classrooms? Solving long division is one thing, but understanding what's happening over here is another thing. So can anyone explain me how do you take it in an understanding way so that your children are pretty comfortable what's happening? At least they have logic to understand that why are we taking down this as an arrow, and what's happening over here, how this 3 became 36, like the way we all have been taught in our schools.
No idea, ma'am. This we all follow the same this method.
How about
They can learn tables like up to 20 in class 5. I'm a primary teacher. So up to 20 tables they know, they multiply and find out same way. They can read the table. Otherwise, this is only the method which we are doing. I don't have any idea of any
No.
other method.
Can I
That's
say,
quite
ma'am?
an honest answer, right?
Yes.
Hello?
So is the yes.
Can I say, ma'am, please?
Yes, please go ahead.
Actually, this is a place value problem because 12 is not multiplied by 1. 12 into 1, not 12. 12 into 10, because we're taking the 10 square. So it will be 120. 12 into 10, 120. And then you have to subtract 156 from 120. Taking down
Okay.
means this is subtraction.
36 is the remainder in that case. No?
Yeah.
12 tens are.
Okay. Now imagine if children would have actually built this concept that they have already learned place value, right? They already know multiplication, they already know addition and subtraction. So till the time they come to division, they're actually well versed with the place value system, the addition, subtraction, and multiplication. But when we actually come to the long division algorithm, we are not leveraging what children have already learned before and not connecting the dots over here. And that's a very good example of using the place value system. And once children see that kind of a connection, and when they play around it, things come naturally to them. So by the end of the lecture, we'll see this, that how we can take this up. So this is the story, a misery story when children are third or fourth grade. And what happens when they come to, like, this is, I guess, a problem of seventh or eighth grade when they learn the polynomial division. What happens then? Can we see as a teacher, I mean, you all know how algebra works. Can you all see that? Is there any relation between this and this? Can you see any relation between this polynomial division and the integer division?
No, ma'am.
Rakhi, hello?
Yes, yes.
Yeah. Hi, this is Bijal here. With the coefficients of the polynomials form the digits.
Okay. So can you think of something which is something interesting happening over here?
X is 10 here.
Oh, wonderful. So when x is equal to 10, when x is equal to 10, so this is 100 plus 50 plus 6, which makes 156. And x plus 2 is 10 plus 2, that means 12. So when x is equal to 10, this polynomial reduces to 156 by 12. Now, is there anyone there to think what x is equal to 10 playing the role over here? Why, when we put x is equal to 10, hopefully you all understood that x is equal to 10 is reducing to the integer number 156 divided by 12. I hope
Here
no,
the
no.
sorry to interrupt. Here I think this is the expanded form of both the numbers. It's written here. 100 plus 50 plus 6. That is the expanded form of 156.
Right. So when x is equal to 10, the problem reduces to the integer division, right? That's what we are doing over here.
Yeah.
How is x is equal to 10 playing the role over here? What is specific 10 thing doing here? And I guess that would be a nice investigation over here. And you all know, I know.
मैथ से बुक निकालो 10.2 निकालो और शॉन 2.2 एक खत्म करना अभी
What is this 10 playing the role? Anyone here?
No idea, ma'am.
Idea is because we all work in a decimal number system. A decimal number system is where x is equal to 10. So this 10 becomes 100. This 10 becomes 100. Can you please keep yourself on mute?
मैथ से बुक दिखाओ मुझे मैं बताती हूँ कौन सा क्वेश्चन करना है
This is 100 plus 50 plus 6 when x is equal to 10, because we are doing all our math in decimal number system. We have got 10 digits, 0 to 9, and that is how beautifully our number system is woven with decimal number system. And that is why when x is equal to 10, our polynomials reduce to the integers. We'll look into it. How do we do it in a better way in a couple of minutes? So let's move to the next slide. Okay, so the first thing what you need to do when you go to the classroom is like, how do you engage your children? How do you engage your students? And that's the ice breaking point of your classroom, basically. Unless and until you don't hook your children with something interesting, you won't be able to engage them for the next 1 hour. So the first 5 minutes in the classroom are more important than the rest of the 55 minutes or whatever your classroom time is. So how can you do this engaging part? So first thing, you need to capture their interest. Unless and until your children are not interested, they won't pay attention whatever you would be saying. So you can pick up a short game related to whatever problem you are solving. You can show them some video clips or some comic strip or picture book or something related to that can really hook them up. The second important thing is that you need to ask, because you know the bigger picture, right? You have to set the stage for their learning. So they can't see the path, but you can. So can you ask them some real world problems related to the concept you are telling? Maybe you're starting with fractions or algebra or HCF LCM. You can create some nice questions in mind, ask them and relate to them in their real world problem. And you can take the basic things, not even the hi-fi things. You can just basic your pencils, erasers, candies, scales, their bags, books, anything what they can relate to. You can create some puzzles and start a dialogue with them, and that is where they will be, hooking to your interest in a way. Another thing, please make the puzzles or anything or your dialogues in a way that your previous concepts are getting connected, as we saw over here in the last problem, that the linking the dots are eye openers. So unless and until you don't open their eyes, they won't open their minds as well. So uncover their prior knowledge, because that is how they would start connecting. And then you show them the bigger picture and the path forward for the given lesson plan. You can do with some mind map or something. You can experiment on your own, that how do you want children to see the new concept in a new light, and that would be the best thing what you can offer to them. Next comes the stage of exploration. Let them explore. So this is where your hands-on and minds-on activity come in picture, and wherein we concentrate more on the concrete objects, the manipulatives, as Ms. Taranjeet said, that she got some manipulatives in the classroom, some nets, some cubes and cuboids and cylinders, and let children experiment them. Even you can pick up basic papers in the classroom, graph papers, grid papers. They can do a lot with them, along with the tools which are available in the market nowadays. But then even that is not enough, because if I have to take to a class, I can take a paper and I can do 10 activities around that paper. So it's not what material you are using, or I can take a rec and rec, or a number line, or 100 chart, but the idea is how innovative you can be with that one product. That is more important. So it's not like that we and generally that's the case, that nowadays kits are available and teachers are taking the kits to the classrooms, but what are we doing with those kits? That's where the differentiation comes. So you have to try to pre-design manipulatives and tasks, and there are a lot of activities available online. You can put a little bit of homework before going to the classroom, and that would set you on the stage. You can make some task cards, you can make flashcards, you can make some thought-provoking questions, critical thinking questions, and put them into the spy mode or the investigation mode, and put them in the inquiry mode, and let them explore on their own. Don't disturb them. You just put the things in the air and let children explore on their own, because the time they are spending thinking, it would be more beneficial than the time you would be lecturing them. So that's very, very much important, children, because they feel powered at that point of time, that we are doing something. Now you can design the activities which are either they can be used as individual task, or they can be done as a group task, because when they do it in the group, because there are different kind of learners. Some people are visual learners, some people are mathematical, actually abstract learners. They are more into the research mode. Some children are kinesthetic learner, they want to actually do the things by hand. Some are audible learners. So different kind of learners, when they come together, they bring their own perspective into the task, and that is very much important. And what this will lead to, which we are missing a lot in our new age classrooms, the cooperation, the dealing with the conflict and the resolution, and the way they prove and disprove their own theory. So for example, a child came up with any notion, any narrative, and the other child thinks, no, that's not true because I think this way. The kind of discussions have in the classroom on those proving and disproving are very, very beneficial for their learning. Now, these two steps were more on the student's part because you have done your homework. You just came to the classroom. You gave them an open field to play. It's kind of their lab where they can experiment, innovate, talk to each other, discuss. And once they have set the tone of the concrete ideas, now comes your role as a teacher, as a facilitator, to explain actually what's happening. So now, whatever they have discovered from the exploration stage, now your role comes at how do you explain them. Now, wherein your initial stage of theory building comes in. So you are already 2 steps ahead what you have been if you're not doing the concrete or pictorial approach. Now, this is the time, this is the right time when you introduce them with the terms and the vocabulary. For example, you're teaching fractions. So now you can tell them what actually numerator is, what denominator is, what actually you are doing when you're taking the LCMs, or you're reciprocating when you are, so basic the thing that we reciprocate when we divide. So those basic understandings, therein where your role comes. So you can have your vocabulary organizers, you can have posters, you can have wall spreads, and they need not to be fancy, but you can just draw them on basic A4 size paper as well. But the idea is if they see something, it retains in their memory, and that's very important. And now, once they have built the concrete understanding, now comes the idea where you are developing the pictorial understanding. Because as soon as you develop something into the pictorial thing, you make a second level connection in the mind that this is how the pictures look like. Because every time they can't carry the tangible things around them. But once they have that pictorial memory inside their brain, they can quickly correlate, okay, so this concept is related to this visual learning or visual diagram or a diagram or something. There are various models nowadays which I love. One of the most, which is the tape model, which is the Singapore based model on which the CPA model is based basically. Then we have area models, we have pictorial diagrams, we have pie charts, bar graphs, and all those we have been learning throughout. And then once they have developed enough understanding on the concrete approach and the pictorial approach, now you can start formulating the problems, the kind of formula we have seen in our maths and mathematical journey. You can start drawing. Drawing is very, very important, and we'll do a couple of exercises and few slides basically that how you can visualize the problems. So draw them in a visual form of choice, and at this point of time, give them freedom, because it's not necessary that tape diagram would be good for everyone. They might like to do the pictorial version and a pie version, or in real life objects version, and that's perfectly fine. So let them explore before restricting them that this is the way the thing has to be done. So that's one of the important tip, to give them the freedom. Once they have understood the concrete and the pictorial approach, next comes your elaborate, because that is where your abstract role comes in picture, which we all have been designed to teach. So here comes the rigid part, the actual formulation we have been learning throughout. So here we have to develop the theories, whatever topic you are on, and introduce the abstract concepts. So now you have to introduce some formal formulae with the task at hand. And at this point of time, it's very necessary to introduce variety of problems, because most of the times, and that's a kind of a funny thing for all our maths teachers, that we teach easy things in the classrooms and we give tough things in the homework and the toughest thing in the exam, right? So that's where the crash happens basically. So introduce variety of problems, especially the corner cases where actually we fall short and we don't look on the corner cases. That's very much important. And then, because till now they have developed the concrete and the pictorial approach, bring in the abstract concept there and then on one paper. So give a problem in such a way that they can play around with the tangible tools, they can develop diagrams, they can develop the pictorial thing around that, and the maths behind it. So once they see everything converging on one paper, all the thoughts coming on one paper, they understand that, okay, so this is what we have been doing so far. So now here comes a very important aspect of the new age math learning, or any learning per se, from fixed mindset to the growth mindset. So when we're in the fixed mindset, we are like, okay, this problem has to be done this way. But when you're in the growth mindset, and that is where the role of the teachers is very, very important nowadays, that can we solve a given problem in different ways? And we need to appreciate that a child can solve a problem in three different ways, and all three different ways are fine. Now which, so it's like from the source to the destination, we all have to go to the destination, but we all can take different routes. Now a child one can take route number one, but child two can take route number two. So we need to come on those grounds which most of the teachers are and it's our system, we can't blame the teachers as well, that it's my way or highway, this is the way you have to do, otherwise you won't get the marks. That is very crucial in any learning, that let's not downsize any of the learning to the grades and the marks, however important they are in the learning. But then if you're not learning enough, grades won't even play any role in the future, right? So that is where we need to change our mindset as well, and change students mindset too, that experiment, innovate, you might be wrong, but that's okay. And once you have set the stage for everything, next, it's the last stage when you have to basically evaluate them. My suggestion is to see where the fundamentals are strengthened or not, to give them the wrong questions. Because when you see something wrong, but you know that this is right, this is the way we have to do it, you kind of develop another level of understanding, because following the rules make you robust, but breaking the rules make you more smarter. So how do you break the rules? That's more important. For example, you gave a division, 56 divided by 12 is equal to 4, maybe something, a basic question. Can a child justify? That justification is more important than learning the division. So why behind what is happening or how it is happening is more important than actually going to the forward part. So when you formulate the problem, so when we do in the computer science, when we code, so there is a term called debugging. So debugs are basically the insects, or basically the bug, the errors basically. When you solve your own errors, you learn more instead of doing the right forward way. So that's one of the very good way of understanding a child's understanding, by giving them the wrong questions. Then, of course, we have worksheets, we have quizzes to how to demonstrate that they have learned enough. So we have got, after the quizzes, you can have the timed quizzes, and try to make the quizzes where you can gauge their more attention and their more understanding than just the fill in the blanks or match the following kind of questions. The tricky questions help them. You can make escape rooms, you can make, there's a wonderful way to make the worksheets that the answer of question number 1 becomes the input of question number 2, and the answer to question number 2 becomes the input of question number 3. So if one thing goes wrong, everything goes wrong, right? So can a child understand that where the things are going wrong? Because that is where the more understanding part comes in picture. Then once they have learned this whole concept, whatever concept you are on, let them present certain problems, make the groups, and the way they would present the problems would be in a different dimension at all. So let the students talk, let them talk their mind, and random students would pick up the random students, because that would help even you and children, that everybody would be prepared. And you can pick up anyone, right? So to save your time, or to have the classrooms well managed in the timeline of your the course system. So that would be one of the things which would help children to get prepared. And then you can ask them, that's a kind of an exit ticket that you understood that concept. You can have some exit test, you can have some journal writing, you can have some anecdotal notes where children can write their own experiences, their own failures, their own good times, their own wow moments kind of thing. So they can actually and what happened inside the classroom or something somewhere where they have helped the students. So if all those kind of things are on one paper, feel a sense of achievement that this is what they have learned throughout this whole concept. And now we come to this whole idea of that how we could start with the basic um, uh, understanding of the abstract thing what we started over here. So before going to the next step, can I ask yeah, exactly. So Ms. Gurpreet is saying the 5 E's of inquiry-based learning. Exactly. So this is how you can plan your classrooms, and you can make the children to the next level. So yeah. So do we have any questions before we go further, more into the experiential stage? So we can have some talking over here. Anything you would have done in among what all five things what we have seen over here, what you have done inside your classroom?
This all we are doing actually. We are asking the student questions, relating it to their real life situations, worksheets, poll game. We are playing games nowadays. We are teaching online, so many things we have.
Great, great. So what kind of poll games that the
Actually,
poll?
we are having OS, operating system, Ryan OS, and in that we have many features.
Okay.
So there we have this poll feature also. We ask them a question, give them options, then we start with the voting type kind of thing, and they select the correct answer. Then the winner's name is coming on the screen of all the students, and so they are excited. They feel very excited. So for every topic, they ask for let us play poll, ma'am.
Yeah, that's pretty
Hmm.
interesting. That's good.
Yes.
So which school are you in, Mr. LG?
Ryan International, Ludhiana.
Ludhiana. Okay.
Yes.
Okay, so let me ask one question, and then you all can come up with your own way of solving it. Okay, so or thinking so think so now we are thinking in the concrete way, but how we can think it in a real life objects, how we can draw, and like we can give you like permission to draw or annotate on the screen, and then how we can go with the abstract way of the thing. Okay, so let me put a question over here. Very basic question, but let's see how can you come up with the different approach in this. Okay, so it's little gone out of the thing. So the font thing. The question is Shreya and her brother shared 40-60 of the chocolate bar. Okay. So whatever is the chocolate bar, they are sharing 40 and 60. So basically, the share is like you can figure out yourself. Her brother gave 2/3 of his to Shreya. Now what is their new share? So now how would you take this basic question to the classroom, and how would you draw it, and how would you solve it in an abstract form? So let's take 2 minutes and figure out how would you do this. You can be as creative as you can.
Can we answer, ma'am?
Yeah, sure, please. Can you annotate on the whiteboard?
No, ma'am. Annotation is not seen there.
Okay.
Maybe you have not given the permission to annotate.
Perhaps. Manish, can we give them the permission to annotate?
Let me just check. Hi, ma'am. Actually, this won't be possible for this session because it is already, has started. The
Okay.
session has already elapsed.
No issues. No issues.
Yeah.
Here we can draw 10 bars. We can draw one rectangular shape and divide it into 10 parts. So 40 parts, 4 parts are for sister Shreya. Can I go ahead, ma'am? Can I speak?
Yeah, please.
So we will make a big rectangle bar and then divide it into 10 parts. Okay. 4 parts for Shreya and 6 parts for her brother. Then out of those 6 parts, again, 2/3 he gave to Shreya. Ma'am, 10 parts, 10.
10 parts,
Sir,
right? This
more
is what
than
you are
10. I
saying.
think 1, 2, 3.
It's 1, 2, 3, 4, 5,
Yes,
6,
10,
7, 8, 9, 10, right?
So four parts belong to Shreya and 6 belong to her brother. And then out
you
of
mean
those
4
6,
parts? 4 parts belong to
Shreya and 6 to her
6 parts belong to the brother, right?
brother. Then out of those 6 parts, again 2/3 given to Shreya. So out of 6, 2/3 of 6 is again 4 parts.
So how will you, okay, so now that's the next, so this is the question where you need to tell children, how is the 2/3 of the brother getting calculated, right? This is what our, so now this becomes a new whole, right?
Yes.
So there, it's not like that a child could visualize that what is the 2/3 of this yellow part, right? So what you need to do over here, that this is the new whole, because the concept of the whole is very much context oriented. Can we keep on start a whole, you started the whole with the chocolate bar, which is of 10 pieces. But now when you are at this point, 2/3 of his. Now this 2/3 of his, this his is the new whole now, which is this new yellow part. And we have to figure out what is the new 2/3 of this part. So this is 1/3. And for this 1/3, this is the 2/3, which he gives to his sister. Which for the ease you can pick up. Okay, so this is one line and this is another line.
Yes.
So basically now, because you can't visualize 2/3 as the starting, because that 2/3, what we are saying, is actually 4/6.
Yes.
So that's the equivalence fraction which comes in
Equivalent
play.
fraction. Yes.
Right. So children need to visualize this, at what you are saying 2/3 is actually 4/6 of the original chocolate bar. So 4/6 of the original is different than the 2/3 of the new whole. So children need to reinforce this concept. When you are saying 80/20, the answer is okay, perfectly fine, because now these two pieces are left with the brother.
Yes. So 20 for the brother and 80 for the 80 for Shreya.
So now the new share is 80/20, where 80 goes to Shreya and 20 goes to the brother. So can you see, when you are working in the pictorial way, you can easily see that what is the new 2/3. But wherein if you are working in the abstract way, how would you do it now? Can you explain the same problem in the abstract way where you don't have any pictorial thing to tell?
आप साइंस क्यों नहीं कर रहे हो?
2/3
आपको
of
टेस्ट
60
देना,
will
तभी
be
मैथ्स
found.
कराऊंगी.
Then
Sorry.
2/3 of 60. We have to find 2/3 of 60 then.
Let's figure it out, what we have to
And
figure
then
out.
add it to 40.
Okay, so first step. What would be your first step when you would start this concept? So we figured out that 40/60 is the first thing.
Yes. Shreya
Right.
share is 40 and brother's share is 60. So 2/3 of 60 we have to find here. After that, it will be added to the Shreya's share. 2/3 of
First
60
step over
is
here
40.
itself is, when we are talking about 40/60, over there you told me take a bar which has got 10 parts, right? It's not talking about 10 parts over here. It's talking something else over here.
100.
It's talking about 100.
Yes.
So now can you relate that this 40/60 is actually 4/6? So 40/60 of 100 has the same analogy as 4 and 6 of 10. And when you're doing it pictorially, you could easily assume it, right? So if you're assuming it, this is actually not one bar. This one bar stands for the value 10.
10.
And that is where we are saying this is 40, the blue parts, and 60, the yellow parts.
Yes.
So basically what was 40/60, if you think about, it's not a fraction, it's a percentage kind of a thing. It's per 100. It's 40 per 100. So that is why it's 4 per 10, or that's 2 per 5. So this thing will go to 4 times 6 or 2 times 3. They're all equivalent. Now when you're saying 2/3 of what? 2/3 of this part. I hope you all are catching up what I'm trying to tell over here. So now the context of the whole is very different in all these three, because 2/3 of 60 is different than 2/3 of 6, than 2/3 of 3. Are you catching up here what I'm trying to tell?
Yes. Yes, ma'am.
Yes,
Yes,
ma'am.
60 is
So
40.
what your
Out
goal
of
is, so when you're teaching fractions, when you have tools in front of you, children can actually experiment instead of just going through the abstract notion of 2/3. 2/3 of 60 is 40, but 2/3 of 6 is,
4.
and 2/3 of 3 is
2.
2. So now can you see that in this case, 2 chocolates go to Shreya. So that means she has got 4 and the brother has got 1. So it's 4 and 1 relation now. Wherein you're doing the same thing, this is 8 and 2. Wherein you're doing the same thing, this is 80 and 20. Everything is related. All the numbers are related if you see in the coherence. So even if you're seeing it in the least common fraction form, or you're seeing in any of the equivalent fraction form, or you are seeing it in the percentage form, or you are seeing in the ratio form, or you are seeing in the decimal form, everything is related, or in the ratio form. So when you see these kind of connections, wherein the fractions, decimals, percentages, ratios, everything come on the same spot, children make connections. Otherwise they would be learning all these concepts in a very disassociated form. I hope you're getting over here what I'm trying to tell, that what pictorial and the concrete understanding brings in before we get into the abstract mode. Okay, let's pick up one more question where we were doing this 156. 156 divided by 12. Now, how can you leverage the place value system over here? And this is going to be very interesting. Take your time, think it through. How could you take it to the pictorial and the tangible form?
Repeated subtraction.
Repeating 100 and like 12 from 156 13 times, that's too much for a child to
Too
think,
much,
and for anyone to visualize basically what's happening over here. Because the idea is I want to correlate the division algorithm, which eventually they would be doing, right? So see, the whole idea is that in our mind the end result is the abstract form, but reaching to the abstract form the way we have been reaching till now is not the right way, because that does not make the connections that helps us in solving the problems. No qualms about that trigonometry, 11th and 12th, derivative, integration, we all have been doing throughout, but did they make any sense to us? No. So here the idea is that to make sense, to pick up the why behind whatever we are doing. So we are doing perfectly fine, we are scoring marks in maths, but then getting to the understanding is more important than solving the questions, right? So that this is what we have been doing. I want children to make sense of this, what they are doing over here.
This is dividing 156 items into 12 equal parts.
Okay, I want over here to understand, why is this 1 coming here, why is this 3 coming here, why are we getting down this 6, where is this 3 coming from? I need to understand, I need to visualize what's actually happening. So that's my underlying theme over here. So we know division as distribution, as repeated subtraction. Can we think it in the terms of number sense, place value system?
Yes, 12, 10 times is 120, and then 12 3 times is 36.
Okay, partially correct. You're quite near.
Can we do grouping using objects, ma'am?
Sorry.
We can group by drawing some objects and then see how many will remain. Now we can take only the 2 digit 15, and then we can draw 15 objects, any object, and ask them to group into 12. So when they group it into 12, they will get one group and the 3 will remain.
One group of what?
Now suppose it is marble. Suppose we have 15 in a group, and if we have group it as 12 in a group, so we can make a
you're
group
saying
of
when you're saying
15.
15, right?
Yeah, 15. Yes, ma'am. Then
Okay.
if we have 15 objects, like suppose it is marbles, and if we have grouped it into 12, when we group, we will get one group, and then 3 marbles will remain in that.
According to your understanding, there will be 15 marbles we will start with, right?
Yes.
And 3
yes, ma'am.
marbles would be left, and then we would be
Left.
having 6 more marbles over here. You are
Yes,
giving
yes,
an
ma'am.
understanding that there are 21 marbles, not 156 marbles.
Okay. No, just to make them understand.
Right. So whenever so to fix something, we will not do something wrong to fix the current problem and create the future problem. You understand my point over here? Right. So when we are saying this is not 15, as a math educator, we need to understand this is not 15, this is 150.
Yeah, even if we take 156, but that number would be big if the kids are small.
So that means we need to develop something more over here to get the solution right? So
yes,
it is not, so it's not that the children are big or small.
Okay, because we can also follow the steps for division. That is, D stands for the first step is divide, then multiply, subtract, and bring down. That is, D will be dad, M will be multiply, that is mom. So these will be the steps. So first we can start off with this number 15. So first, if we have to divide, so like it is like D for dad, M for mom, S for sister, and B for brother, bring down. So these will be the steps for division. So we can start off with these steps. That is, first we will check.
Okay. So
yeah.
So we will try not to do these things at this stage, okay? Because we want to build up their conceptual understanding instead of giving them these acronyms and shortcuts, okay? So, I mean, we all have been doing this, but now we can break these shackles basically so that whatever we are doing is not correct in a way. So, okay, so let's leverage, because we all know place value system. So this is a box. Okay, and I call this box as this is hundreds box, this is tens box, and this is ones box. Basic. This is a basic thing. What we are doing is we are not letting anything new come over here. We are leveraging what they already know, their prior knowledge. So let's pick up what do you think should happen over here? Any idea? Any suggestion?
One.
Okay, 1 over here.
5 here. 5.
5 over here. Okay.
6.
And 6 over here. Easy, right? A child can understand that this is 156.
Yes.
Now we have to make the groups of 12. How do you think a 12 would look like? Tens and ones? How do you think a 12 should look like?
1 and 2.
1 and 2? Basic thing. Any child who is coming to the division concept will be knowing this thing for very sure. What do you think now we should do? We need to find the groups of 12, right? So that means we need to find this pattern over here. Can you find one pattern over here? Is this 12?
No.
What it
Yes,
is?
we can take one from tens and one from two from ones.
Okay, let's start from the left hand side as the rule, right? We start from the left hand side. I mean, we can do it from any side, although when I'll do, but right now, to taking to the children and maintaining the consistency, let's take one from the hundreds and two from the tens. Can we do that? What is the circled number, if
Yeah.
anyone can figure out?
That will be 120.
120.
120, very good. That's 120. And basically, you are making one group of 12, which is on the tens part. One group, right? You're forming one group of 12, which is this one. And this is, if you see again over here, this is hundreds, this is tens, and this is ones. This is one group of 10. This is one group of 10. And this 12, what you have written, is actually 120. This is 120. This whole thing is 120. What you are left are these three stars. These are actually 30. You're just not writing. This is actually 30. And what you are saying that bring it down with writing B with the brother or something, the acronym you are giving, this is actually this 6. So now you are left with 3 stars in 10, that is 30, and 6 stars in ones, which is 6, which is cumulative, making 36. Now again, can you find this group of 12 in this 36?
One from tens and two from ones. 3 groups can be made.
So
One
three
group,
groups can be
one
formed.
Because this
can
is
be
12.
12.
This is
Yeah,
another
3
12.
groups can be. Yeah.
That is 24. And this is
One more.
third one, which is 36.
Yes.
Can a child relate now what is happening?
Yes.
Absolutely.
Let me give you one more, but without giving this concept. Now you figure out on your own, does this work? So let me give you something. So let's do this. 276 divided by 12. Or let's do 276 divided by 13. So let's do this.
Ma'am, can we take a number which is ending in odd number over here because the previous
We will get remainder here.
yeah so can
we
we
are
do
not get sorry. This has
That
to
was fine. 276 divided by 12.
be 12. Sorry, the quotient actually it's gonna be 23. I had to write 23. I wrote 13. So either you divide by
I'm saying instead of 276 can we take it 275?
You take 276. Why I want 275 help? Over here, either you do by this or you do by this. So basically, 12 times 23 is 276. So either you can do either of these things.
Yes.
My mistake. I had to write 23. I wrote 13.
No, my point is, here it will be completely divisible, right?
Right. So you don't
But
want to get it completely?
yeah, so
You can do it
the
277.
yes,
You can
yes.
do 277.
The previous example that you gave was completely divisible.
Right.
So now we take another example which is not completely divisible then.
And that's perfectly fine. So you would be left with few of the stars over there.
And that will be remainder.
And that will be the remainder.
Yes.
So the whole idea is if you get them into the pictorial form, and children have come up with some amazing ways over here. So basically this is one of the method which we use a lot. Being a global math ambassador for India, we do a lot of these things in exploding dots. So basically there's a concept of like a positive dot. So positive dot and a negative dot. So red shows you a positive dot and yellow shows you the negative dot. So if you have to represent, let's say 19, you can draw one red dot over here, one red dot over here, or 9 dots over here. That shows 19, right? And children are so smart, and their first question, as soon as they draw, because kids are smarter, but then they're like sort of lazy. Their first question was, can we do this? That if we draw 2 dots over here, 2 red dots over here, and 1 yellow dot over here, are they both equal? And they both are equal. Because 10 and 9 ones make 19, whereas 2 +10s, this is 20, and 1 -1, that's 90, that's -1, makes again 19. So once you give them the visual tools, they will come up with their own way of thinking, which you wouldn't have ever imagined. So the abstract way is a good way to develop the basic math understanding. But then if you give them the visual and the tactile tools, they are more inclined towards learning and failing and learning from their failures. So there is no sort of right or wrong. It's like encourage children to ask all sort of questions: what is right, what is wrong, because everything leads to some other theory. So focus on the reasoning. Even if they're asking the wrong question, or even they're giving the wrong answers, focus on the reasoning behind that why a student is even thinking so, because that would lead them to the discovery based approach. And that is where a lot of theories come into picture. So that is what my take on lesson planning for your CP approach was. And then we can stay back for the questions and your insights. And please do fill the feedback form after the session so that you all can get the certificate, and we get the feedback how the session was. So yeah, so open to you for questions or the queries.
Hello, ma'am. Can I listen?
Yes.
Yes, ma'am. This actually the questions of Shreya and his brother based on that. So is this a CPA model or this is bar model of teaching process?
So see, CPA, this is bar model. CPA is basically the concrete, right? Anything can be concrete. Anything what you can touch with your hands is concrete, right?
Yeah. So basically
Now
this is bar model of teaching process.
Right. So now the pictorial model is basically, now you can take this in the form of the tape, the bar model, which I have shown, which people call it tape model as well. You can show the same thing in a circular way as well, right? It's not like you have to show this.
It's not circular. You can take circular also. It's not in circle
Right.
also. Bar also we can.
Right. So the idea is you can take any of the picture form, any of the visual form. Right. So that is what the idea of CPA is. You give them tools in hand to experiment. There are Kuznets rods, there are unifix cubes, there are base 10 blocks, and there are a lot of things over there, right? So in the market or in the kits available in the schools, in the labs.
Yes, ma'am. Okay, thank you, ma'am.
And then you can take them to the any of the picture visual way to show up the things, and then you lead them to the basic mathematical concepts what you take up.
Yes, ma'am. Thank you.
Most welcome. Is there anyone who has to ask something?
Ma'am, I'm not able to find the feedback form.
Okay, that
The feedback forms will be sent directly to your registered email IDs.
Okay, fine.
You shall receive those the email after the session is over, like
Okay,
within 5 to 10 minutes
fine.
after the session ends. All right.
Fine. Thank you. Thank you, ma'am.
Yeah,
Thank you, sir.
You're welcome, ma'am.
Ma'am, this division which you showed using diagram, it is just like the dot method.
Sorry, your voice is not clear.
Ma'am, the division that you showed using place value, it is just like the dot method of division.
Ma'am, your voice was not audible at all.
Okay. This division which you showed just now, it is just like the dot method of division.
So what I guess you're trying to say is the division method we showed during the session, is it a bar division method?
No, it is
Right.
the dot division, dot.
Dot division.
Dot
Yes.
division.
Yeah,
Yeah.
yeah. It's just like that. Yes.
Yeah, exactly. And you can also do this with the block 10 base blocks, right? So you
Yeah,
pick
yeah.
up your 10 blocks, and now you ask the child, right? How would you show it? So it's like 120, right? They can pick up,
Yeah.
you can pick up 100 blocks, right? And 100
Yeah.
block and 10 rods.
Yeah.
And that's one set of 12. And then
Yeah.
you're left with three strips,
Yes.
and that's 30. And then you have
30.
got 6 small ones, right?
Yes.
That's 36. So the whole idea is basically, can a child relate to what you are showing? If they can relate to, fair enough. If they cannot, then of course we need to build these system for a child to understand that what's working and what's not working. So over here, this is your 120. You're
Yeah.
left with 3. So again, this is the concept of this is the leftover 3, which is 30. And then you have 36. So this one rod goes with this 2. This one rod goes with this 2. And this one rod goes with this 2, making 3 groups of 12. So
Yes,
one group of 10 and 3 groups of ones, that makes 13, right? So the idea is to get on hang that basically what's happening without even going directly to the abstract form, the sort of like the long division algorithm, which is quite confusing for most of the children, including me when I was at that age. So hope this was a useful session, and hope you can take something from here to your classes and make your classes more interesting and engaging.
Thank you so much, ma'am. I would like to thank all the participants for being patient with us, and I'd like to thank you for delivering such a beautiful session. Requesting everyone to just visit our website. Whoever is not able to open the link and the link which was shared in the chat, if it is showing error, I would request you to just simply visit our website www.schanpublishing.com and find yourselves towards the CPD corner, which is shown in a banner on the left hand side in the middle of the page. All right. Otherwise, the link shared in the chat should work in a bit. Maybe due to some technical issues, the link is not working. Otherwise, it should. Again, thank you so much for your participation, and please look out for the feedback email on your mailboxes. If not received, please check your spam boxes. and do fill the feedback form to receive the certificate for participation. Thank you so much. Thank you so much.
Thank you so much, Manish, for
Thank
having
you.
me. Thank you. Bye-bye.
Hello, sir.
Bye-bye.
Hello.
हाँ जी बताइए.